Hi, this video is for Wednesday, March 25th for calculus. Today we're going to review how to find limits analytically. Yesterday we reviewed how to find limits from a graph or table. So analytically means we're going to use this idea of direct substitution. Well, we're going to try anyway. We're going to plug in what the x value approaches into our function, and we're going to simply compute what that equals, and that will be our limit. Now, this only works for functions that are continuous. That means there are no gaps, there are no holes, there are no asymptotes. So, direct substitution only works for graphs that are continuous. Okay, so we're going to go to example 1. So example 1 on your notes looks like this. It says evaluating basic limits. The first one says find the limit as x approaches 2, and our function is simply the number 3. Well, there isn't an x in our function for me to plug 2 into the function, so the limit is just 3 because that function is always equal to 3. It's just the number 3. So this one equals 3. Okay, so that's part A. Part B says find the limit as x approaches -4 of the function x. So we're going to plug in our -4 into our function here. So if you plug in -4 for x, the limit equals -4. So that's it for the second one. Okay, so part C on example 1 says find the limit as x approaches 2, and the function is x squared. So if you plug 2 in here, 2 squared is 4, and so the limit is 4. Alright, so that's example 1. Now we're going to look at some basic properties, basic limit properties, but we're still going to use the idea of direct substitution. So if you want, you're very welcome to read that box that says Theorem 1-2, Basic Limit Properties. I'm just going to demonstrate how those work on example 2. So if you scroll down to example 2, example 2, they give us two functions and their limits. So it says if the limit as x approaches 2 of f of x equals 2, and the limit as x approaches 2 of g of x equals 3, we're supposed to find each of the following. So part A says find the limit as x approaches 2 of f of x plus g of x. Okay, now, since they already told us what those values equal, we can substitute their answers in. So 2 is going to go in here for f of x because the limit as x approaches 2 of f of x is 2. So this part's going to become 2. And the limit as x approaches 2 of g of x is 3. So 2 plus 3 is 5. So the limit is 5. Okay, so there I'm just substituting in what these equal into what they want me to do, and then adding them. So 2 plus 3 is 5. Okay, next one says, so this is still example 2, part B. Find the limit as x approaches 2 of 5 times f of x plus g of x squared. It's like that. And if you look back at your notes there, the limit as x approaches 2 of f of x is 2. So I'm going to substitute a 2 in here where it says f of x. And the limit as x approaches 2 of g of x was 3. So we're going to plug in 3 for g of x and square it. So 5 times 2 is 10. 3 squared is 9. So 10 plus 9 is 19. So that's it. Okay, so now they're going to give us a function, for example 3, p of x. And they're going to tell us what to plug in for x to evaluate the limit. So example 3, it says p of x equals 3x squared minus 5x plus 7. And we're supposed to find the limit as x approaches 2 of p of x. So what this means is you take your 2 and you plug it in up here for x in both of those spots and you evaluate. So we're going to have 3 times 2 squared minus 5 times 2 plus 7. So 2 squared is 4. 4 times 3 is 12. 5 times 2 is 10. And then we've got that plus 7 at the end. So 12 minus 10 is 2, and 2 plus 7 is 9. So the answer is 9. Okay, so we've got one more example of direct substitution to evaluate limits, and then you will have a Google form on these ideas that I've posted to Classroom. Okay. Alright, so here we go. Example 4. Find the limit as x approaches negative 1. And then here's the function. 3x squared minus 5x plus 1. And all of that is divided by x to the 4th minus x squared plus 3. So we're going to replace every x up there with a negative 1. And then we're going to evaluate it step by step and then simplify. So as you can see, I just plugged in negative 1 every place that had an x, and now we're going to simplify. So negative 1 squared is 1, and 1 times 3 is 3, minus 5 times negative 1. Well, 5 times negative 1 is negative 5, but because of this minus, we're going to have plus 5, and then plus 1. And then on the bottom, we're going to have negative 1 to the 4th, which is 1, minus negative 1 squared, which this is 1, so we're going to subtract 1, and then plus 3. Okay, so let's see what this equals. 3 plus 5 plus 1 is 9. 1 minus 1 plus 3 is 3. And finally, 9 divided by 3 is 3. So the final answer there is 3. You just had to do some algebra to get there. Okay, so if you have any questions, you can email me. I've posted this video along with the notes to Google Classroom, and the form for today is there as well. So that's it. See you later.